So in the previous class we have learned about we have started module 3 and we have learned about Lagrangian interpolation, is it? So this class we can learn about Hermition interpolation, how to solve using Hermition interpolation. So here we have to find, in Hermition interpolation we have to find y of x. So that y of x is given by the formula a1 phi 1 plus a2 phi 2 plus etc plus an phi n. Okay, so if x and y values have been given, that is x value range from x1 to x4 and y value ranges from y1 to y4, which is given in a table like this, then you can find the value of phi 1 by using this equation, that is x minus, if you are finding phi 1, then your equation will change to x minus x2 into whole square into x minus x3 whole square into x minus x4 whole square divided by x1 minus x2 whole square into x1 minus x3 whole square into x1 minus x4 whole square. So here x and y values are given. So here x value range from 1 to 4. Okay. Therefore our equation will be this much only. If it contain again additional term, that is if it contain an x5 term, then equation will be changes to x minus x2 whole square into x minus x3 whole square into x minus x4 whole square into x minus x5 whole square and so on. Okay. So if the term increases, then equation's length also increase. Now you have to find, here you find the value of phi 1. Now you have to find the value of a1, a2, etc. an. So in common you can take it as ai. So to find ai, so it is given as ai equal to yi into 1 minus bi plus yi dash into x minus xi. And bi is given as 2 into x minus xi into sigma j equal to 0, j not equal to I to n 1 by xi minus xj. Now you can solve a problem using what? Hermition interpolation. So fit a polynomial using Hermition interpolation and find the value of ln 0.6. So you can find by using this form. You have to study this for solving the problem. Okay. So here x value is given as 0.4, 0.5, 0.7 and what? 0.7 and 0.8. Okay, so let's start solving the problem. Now x value is given 0.4, 0.5, 0.7, 0.8. Corresponding ln x value will be, so you are taking y equal to ln x. Okay, so corresponding ln x value will be what? Ln of 0.4, that is minus 0.91269. Then ln of 0.5 minus 0.693147. Then ln of 0.7 minus 0.356675 and for 0.8 minus 0.223144. Okay. Then you have to find the value for y dash. So y dash is required for finding ai, is it? So y dash is equal to 1 by x. So 1 by 0.4, then 1 by 0.5, then what? 1 by 0.7, then 1 by 0.8. Those values have been given here. Then next you have to find the value for phi I. For finding the value for phi I, you will have to find what? You have to, first of all, you should know the equation, that is y phi I equal to, if it is phi 1, then it will be equal to x minus x2 whole square into x minus x3 whole square into x minus x4 whole squared by x1 minus x2 whole square into x1 minus x3 whole square into x1 minus x4 whole square, is it? So here we have marked the values x1, x2, x3, x4. Okay, so x1 is 0.4, x2 is 0.5, x3 0.7, x4 0.8. Now substitute the values here. So phi 1 equal to x minus x2 whole square, is it? So x is 0.6. Then x2 value is given here as 0.5. Then into x minus x3. x3 value is 0.7. Then what? X minus x4. x4 value 0.8. So substitute the value, find the value for phi 1. Similarly, in case of phi 2, equation will be x minus x1 whole square into x minus x3 whole square into x minus x4 whole square whole divided by x2 minus x1 whole square, x2 minus x3 whole square and x2 minus x4 whole square. So you can find the values here. Again phi 3. So for finding phi 3, equation will be x minus x1 whole square into x minus x2 whole square into x minus x4 whole square divided by x3 minus x1 whole square into x3 minus x2 whole square into x3 minus x4 whole square. So find the value. Similarly, you can find the value for phi 4 also. Next you have to find the value for bi. So here you have to find b1, b2, b3 and b4. So first of all, b1 is given by using equation 2 into x minus x1 into 1 by x1 minus x2 plus 1 by x1 minus x3 plus 1 by x1 minus x4. So substitute all those values. You can find the value for b1 as minus 6.3333. Next you have to find b2. So b2 is given as 2 into x minus x2 into 1 by x2 minus x1 plus 1 by x2 minus x3 plus 1 by x2 minus x4. So substitute the value, find the value for b2. Next you have to find b3. So b3 is given by 2 into x minus x3 into 1 by x3 minus x1 plus 1 by x3 minus x2 plus 1 by x3 minus x4. Similarly, you can find the value for b4 as 2 into x minus x4 into 1 by x4 minus x1 plus 1 by x4 minus x2 plus 1 by x4 minus x3. So find the value for b4 also. Now after finding that, you can find the value for a1, a2, a3 and a4. So you have found the value for what? yi, bi, yi dash and also xi. So substitute the values and find it. So y1 value. So y1 is obtained here as what? Minus 0.91629 into 1 minus bi. b1 value obtained as minus 6.333. So substitute the value here. Again substitute the value of this. You can find the value for a1. Similarly, you can find the value for a2, a3 and also a4. If you have to find the value for a2, equation turns out to be y2 into 1 minus b2 plus y2 dash into x minus x2. So substitute the value, find for a2, then a3 and a4. Next you have to find the value for ln of 0.6, is it? So ln of 0.6 is given by a1 phi 1 plus a2 phi 2. So a1 phi 1 plus a2 phi 2 plus a3 phi 3 plus a4 phi 4. So substitute the value for a1 phi 1, a2 phi 2, a3 phi 3 and a4 phi 4. Okay, then summation of all these will give you the value for ln of 0.6, that is minus 0.51181. Okay, So this is how you can solve a how to solve using what Hermition interpolation method. Okay, so this is how you can find a polynomial using this. That's all about Hermition interpolation. Next part we have to study about curve fitting. So